Hello and welcome to the third part of our fifth lesson of the third unit, Solving Quadratic Equations. This is for our MCF3MI class. This final example, as I said at the end of the last video, has a bit of a curveball. It's essentially the same style of question with a small deviation in the way that we figure out the length and widths of our combined rectangle. Let's get into it. A dining room measures 5 meters by 4 meters. A strip of uniform width is added to two adjacent sides to increase the area to 25 meters squared. Find the width of the strip to one decimal place. As before, we're setting up our let statements. Oh, I should make a little fix here because I always write W's here, and what I mean is X. So there's our X. So our two let statements. Let A represent the area of the extended dining room. That's the dining room and its new extension combined in meters squared. Make sure you get the units on there. Let X represent the width of the strip in meters. So, as before, let's start with our diagram. And we need to find the length and the width of this rectangle in order to calculate the area. Now, what's interesting this time is because we are adding a uniform strip on only two adjacent sides, and adjacent means beside, so two sides side by side, we're not adding to all four sides of this shape, which means that when we look at the length, what we have is the 5 meters and only one x this time. No big deal. That just means that our length is going to be x plus 5. And the same thing when we're calculating our width. We have the 4, which we can see, but we've also got only one x this time. So that means we have 4 plus x for our width. No problem. That's the little deviation, is that sometimes questions will ask you to add a uniform width only to two sides as opposed to all four, which just means that the length and width you determine, it won't be 2x, it'll just be a single x. Okay, let's get down to the calculating. So the area, of course, will be the length times the width. The area combined is going to be 25 meters squared, and the length was 5 plus x. And the width is going to be 4 plus x. As before, we're going to expand out and get all of our terms on the same side to end up with a quadratic equation that looks like it's in standard form, something we can either factor or use the quadratic formula on. So we have 25 equal to, and we're going to just FOIL this bad boy, making sure every term is multiplied by the other. And that's going to give us 20 plus 5x plus 4x plus x squared. Now we're going to combine like terms, and in that same step I'm going to transpose 25 over to the other side by subtracting 25 from both sides. That's going to give us 0 equals, and again I'm going to fix the order of these terms so they more closely match what you would expect in a standard form version of a quadratic equation. X squared plus 9x minus 5. Now this is not going to be factorable for us, so we're going to be using the quadratic formula again. We know that our a value then will equal 1, our b value will equal 9, and our c value will equal -5. There it is. So we're going to plug this into the quadratic formula. I will set that up over here. So we've got, and again, I'm not going to rewrite the quadratic formula. You guys can do that if it helps you. I'm just going to jump right into substitution here. So we've got x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's just check I did that right. Yep, that looks great. So we are now going to simplify this. And again, I recommend just doing this in one step. I'm just going to bang this whole thing into my calculator. So we've got 9 squared minus 4 times 1 times -5. And that's going to equal 101 all over 2. So here we are at that place where we have two possible solutions. The first will be what will happen if we take -9 and add it to root 101 before dividing by 2. And the second scenario, where we see what will happen if we have negative 9 subtracted by the root of 101 before being divided by 2. So let's run these through our calculator. We have negative 9 plus square root 101, that's an equals, and then divided by 2 equals 0.5 is what they were asking for. I think it was 1 decimal place. 0.5. And let's work the second piece as well. So we've got negative 9 minus root 101 equals, divided by 2 equals, so x equals negative 9.5. So as with the other questions, one of these is inadmissible. It will be, of course, the negative value, and it's inadmissible because we can't add a negative 9.5 length to a room. It just doesn't work that way. So we have 0.5 as our answer. Now we just pop a little therefore statement on there. Therefore, how did they refer to it in the question? The dining room was increased by 0.5 meters. And there is our therefore statement. And our final example from this lesson. So give this homework a try. The one with the asterisk down there is a challenge question. So if you can't tackle it, that's no big deal. The other one should certainly be gettable for you. There's the worksheet and then just a few from the textbook. So good luck. This is the last lesson of Unit 5, and yeah, hopefully the unit is making a little more sense to you now.